So if this is a parallelogram and we want to express O to Y, well, O to Y is going from here to here. Okay, and we can get there in two different ways. We could either go from O to Z and then from Z to Y, or we could go from O to X, then from X to Y. So two different routes to get there, and vectors is all about those routes. And notice I've done these colours on purpose so you can recognise that this is vector A and this is the same as vector B because we're a parallelogram. So they're parallel lines of the same length. So they are exactly the same vectors because a vector is a description of motion or how to get from one place to another. I place that vector wherever, and those two vectors on the left and right, they're identical vectors. They may start and finish in different places, but they describe the same movement. So Z to Y is the same as O to X. They're both B. And O to Z is the same as X to Y. They're both A. So to express these vectors in terms of A and B then, O to Y then, that blue line, we're going to be going along A and then along B, or along B, then along A. So overall, O to Y would be A plus B. Y to O is a bit different. Y to O, we are no longer going from O to Y. We're going along the same line, but in reverse. So from Y to O, to go in reverse, we could go from Y to X and then from X to O. So Y to X is going backwards down A. So that is negative A. And then from X to O, which is backwards down B, which is negative B. Remembering that a vector in reverse is the negative of that vector. From X to O is negative B. X to Z then. X to Z goes like this. This time to get from X to Z, I could go from X to O, and one way I could write this is write it out specifically. I could, and this could help later, I could go from X to O, and then go from O to Z. This is that other way of writing it, X to O, then O to Z. And we know X to O, well that's backwards down B, so that's negative B. And then O to Z is along A, so that's a positive A. Finally then, Z to X, we could go from Z to O, and then from O to Z. O to X, sorry. Z to O is going backwards down A, so that's negative A. And O to X is going up B, so that's positive B. And we're done. And if we'd gone any other way to get to the same place, we'd still end up with the same answer. For example, Z to X, we could have gone from Z to Y, which is positive B, which we got here. And we would have then gone backwards down A to go from Y to X, which is negative A. So we'd have ended up with the same thing no matter what route we took, because the vector describes how to get from a place to another place. And it doesn't matter what route you take, you still get to the same place. Okay? So that's it for that.